Hello, this is Mrs. Ross, and this is 1.1.5, Operations with Complex Numbers. This is the activity, so this is the video part 2. So I'm just going to work through these. The wise thing would be for you to work through these and then check your answers. Okay, so, and then you can check and see all of the work that I have. So let's do A, 3 plus 2i minus 4 minus 5i. So remember, this has an invisible -1, so I have 3 plus 2i, and I have to distribute this. Okay, then I'm going to combine like terms. And my answer is -1 plus 7i. Okay, let's change colors and do B up here. So I have -3i times 4 plus 2i. So I'm going to distribute. So -3i times 4 plus -3i times 2i. Okay. -3 times 4 gives me a -12, my bad. Plus, and then I have -3 times +2 is -6. I times I is I squared. We know that I squared is equal to -1. So this would be -12i plus -6 times -1, which is -12i plus 6, or 6 minus 12i. Either one works for me. Let's see if we can fit one more before I start erasing everything. Okay. C is 1 plus 3i divided by 3 plus I. So I'm going to have to multiply by the conjugate. Okay. And then this means I'm going to have to FOIL. That is not how you spell FOIL. There we go. So I have first 1 times 3 is 3. Outside minus I. Inside plus 9i. Last is minus 3i squared. Over 3 times 3 is 9. Minus 3i plus 3i minus I squared. Okay, let me get a different color here, just for the sake of, yeah. Okay, so we're going to combine this. So I have 3, that's going to be plus 8i, and then we know that this is -1. So this is actually going to be plus 3 over, I sure hope you guys can see this. These cancel, and this is -1, which makes it positive, so that's 9 plus 1. Let's combine our 3's, so we have 6 plus 8i over 10. That's fine with me. I don't know if they want you to pull out a 2, or if they want you to reduce it, or what have you, but that's perfectly fine with me. You can reduce it. You can do, here, let's go up here. 6 over 10 plus 8 over 10i, and then reduce it by dividing by 2. So 3/5 plus 4/5 I. I guess that's probably the best way to do it, is to reduce it. I'm going to pause, erase all of this, and answer 2 and 3. Oh, I still left some. Let me get rid of some of that. Sorry, just fast forward through this part, and there we go. Okay. And then we need a pen, and we need something that's not orange. Great. Can the product of complex conjugates be negative? Justify your answer. So let's see. So before I answer that one, let me solve this one because it's fairly quick. So I'm going to subtract 72 from both sides. I have 2x squared equals -72. Divide by 2, divide by 2. The 2's cancel. I have x squared is equal to -36. I square root. I get x is equal to -6i or +6i. This is the square root of -1 times the square root of 36. So square root of 36 can be either 6 or -6, and that's why we have those. All right, back to the product. I don't think so is my answer. Like, let's take a conjugate. Let's take 8 plus I, and let's multiply it by its conjugate. And we get 64 minus 8I plus 8I minus I squared. What if I made that positive, which would make it plus I squared? But still, that's 64 minus 1. What if this was, what if it was 1? 1 times 1 is 1. This is just me kind of like throwing spaghetti at the wall, sorry. It doesn't look like it. I'm going to say my answer is no, because even if it's like -2, when you multiply those, you're going to get +4 minus 1. So I'm going to say no. All right, let me know if you have any questions.